Hello, everyone. In this video, we will look at the multiple choice questions in chapter 8 of the Java book. First question, which of the following statements are true? Every recursive method must have a best case or a stopping condition, so that's true. Every recursive call reduces the original problem, bring it increasingly closer to a best case until it becomes that case. That's true. Infinite recursion can occur if recursion does not reduce the problem in a manner that allows it to eventually converge into the best case. That is also true. Every recursive method must have a return value. No, that's not true. You may have a void recursive method that does not return a value. A recursive method is invoked differently from a non-recursive method. No, that's not true either. All right, so let's look at the next one here. Fill in the code to complete the following method for computing factorial. So this is the here. So this is the best case and is 0 return 1, else return. So now you're going to return this n times factorial n minus 1, or you can do it factorial n minus 1 times n. Next question. What are the best cases in the following recursive method? So here, if n is greater than 0, we're going to do it recursively and here. So first we print this. Now, if n is less than or equal to 0, so that is the best case. So that's the one, and the recursive method stops. Next question, analyze the following recursive method. So here you have this factorial and you have this n times factorial n minus 1. So this, all right, so for this one, there is no best case, there's no stopping condition. So this, the method runs infinitely and it causes a stack overflow error. Next question, how many times is the factorial method in listing 18.1 in the book invoked for factorial 5? So that's the, if you count the when you invoke this factorial 5, so first is 5, and then 4, and then 3, and then 2, and then 1, then 0. So this be a 6 times. Next question, which of the following statements are true? A Fibonacci series begins with 0 and 1, and each subsequent number is the sum of the preceding 2 numbers in the series. So I think this is true. So, but let's look at the others. Fibonacci number series begins with 1 and 1, so no, Fibonacci series begins with 1, 2, not 1, 3. So that's not right. This is the A. Next question, how many times is the fib method in listing 18.2 invoked for this fib 5? So you can do a manual count, but you're going to see here is it is 2's power 2's power raised to 5, so that minus 1. So I think this is so that's 16 minus 1. It should be 15. So that's the one. If you look at all the numbers, it's going to be this 15 here. All right, next question here. fill in the code to complete the following method for computing Fibonacci numbers. So this is the Fibonacci number, index is 0, return 0, 1, return 1. And now you're going to return the previous two numbers add together, either this or this. That'll be fine. Next question. What is the return value for X method 4? So here is, you're going to invoke this is 4. So here is 4 plus, and this is a 3. So then becoming 2, and then plus 2 and plus 1. So the final one is 1. So you add all this together, it is 4 plus 3 plus 2 plus 1, that's 10. All right, next question here. Fill in the code to complete the following method for checking whether a string is a palindrome. So now this is one of the best cases. S dot length is less than or equal to 1, so that's true. Else, so if the first one, the character at the beginning is not the same as the character at the end, so you're going to return false. So that's the one A. So the others are not correct. This is wrong index, and this is wrong index, this is wrong index. Next question. Analyze the following code. So we have this is the array, and so here is the array, and this is the length here. So now you have this is the 5, the length, but so let's see what happens here is, so you're going to do this, invoke this recursively every time you're going to print the last one. So for this, you are going to print this last one, but when it stops, so that's the problem here. You don't have stopping conditions to keep doing this length minus 1. So once this length minus 1 becomes 0, so you're going to come back 0 minus 1, it's negative 1. So this you're going to get the array index out of bounds exception. So you're going to print this 5, 4, 3, 2, 1, and then you're going to get this array index out of bounds exception. Next question, in the following method, what is the best case? So here, this n is 1, returns 1. So that's the case, n is 1. So this is the one. That's the best case. Next question. Fill in the code to complete the following method for checking whether a string is a palindrome. So this one here is you have the helper method here. So this is the going to invoke this is string, and this is the low, and this is the high. So this is if high is less than low, now returns true. And if this first one and the last one do not match the character, and returns false. Else, we're going to reduce it. Is return is palindrome, and this is the one here. You're going to move this low one position to the right, and high and one position to the left. So this is the one. Next question. Fill in the code to complete the following method for sorting a list. So here's the list right here. It's array. And you're going to sort it. So now you're going to invoke this helper method list, and the high is the last index in the array. So this is going to be this one, C. So this should be this index, okay, of the last element in the array. Next question. Fill in the code to complete the following method for binary search. So for binary search, this is the helper method to recursive binary search for this array and to search the key, and this is low and high. So the index starts from 0. So you're going to have this is low is 0 here, and high is this. So it's going to be D. Next question. How many times is the recursive move disks method invoked for 3 disks? Now for 3 disks, it's going to be 7 moves. And for 4 disks, so how do you know how many? It's 2's power raised to 4, and that is 16 minus 1, it's 15. Next question. Analyze the following 2 programs. So there's 2 programs here. Now this one here, min, so length, and this is greater than 1. So we're going to get this length minus 1, and now continue to invoke it. So this is keep going. So this is actually fine. This will be fine. This is A is fine. Now B is the problem here, the while loop. So it's using while loop. So while this is true, and you are going to do this, okay? All right, so now, and you're gonna keep back, then you have another one, so you have another one. So it's just that this is going to go indefinitely. If you end up with this is the 1, so this is going to be the last one. It's going to go for forever. It's 1, and this is the 1 here. This is the length is when it's 2. So why this is true, just keep going. This is because it's 2, it's true. So you are now doing this recursively. I think the best way is to test this program to run this 2 and see what happens. So this is just be careful. You don't use Y for this condition. You always use F here. So I think this is the E is the answer. Program A produced the correct output. So that's 4, 3, 2, 1. And program B prints this 4, 3, 2, 1, and then 1, 1, 1 indefinitely. All right, next question. In listing 18.9, to draw 3 smaller triangles recursively, the program invokes, so this is the order is going to be reduced, that's true. It invokes, it invokes 3, so you have to do this 3. So here is, if you look at this, it's P1, so 1, 2, 3, 1, so that's right. And then you have this is P1, 2, P2, and then you have this is P 3, 1, 2, 3, and 3. So that is correct. And this one is, it doesn't, P1, 2 is here, 2, 3. No, that's not right. This is not. All right, so which of the following statements are true here? Recursive methods run faster than non-recursive method. That's false. Recursive methods usually takes more memory space than non-recursive methods. That's true. A recursive method can always be replaced by a non-recursive method, and that is also true. You can do that, although it may take a lot of effort for some of the programs. In some cases, however, using recursion enables you to give a natural, straightforward, simple solution to a problem that would otherwise be difficult to solve. That's true. All right, so now let's look at the section on tail recursion. Analyze the following functions. So this is 2 functions here, F1, F2. So here, this is F1. So you add this numbers together. So this is invoke n, then plus n minus 1, then plus n minus 3. So this is the one. And this one here, we're using this tail recursion here. So this is the result. And here, when n is 0, return result, but you're here adding some in this part. So yes, F1, no, F2 is a tail recursion, but F1 is not. So that is the correct answer. I think that's the one. Yeah. So next, show the output of the foreign code. So this is the output. This is tail recursion. So this one here, you're going to start from 2, and then 2 plus result, you pass this result to 0, so it's 2, and then becoming 3 plus 1, so it's 3. This is the one. This is the answer. The last question: what is the maximum number of the activation records when running compute factorial tail recursion? So you can do it with animation and to see how this works with the tail recursion if the system supports tail recursion. So what it does is you have the you're going to count the min is 1, and then you have that overloaded function for the factorial, the tail recursion. The normal the recursive call, then you have a tail recursive. So this going to be min, and then that's actually 3. It's 3 should be the answer here. So if you look at everything here, so that's going to be and the answer here. Okay, I'm going to check everything, see if we got it right. Okay, now we have wrong answers. So we see which one is wrong. Okay, so this one is wrong. And the reason it is wrong here, okay, I think this is tricky here. Because you're doing here return 0. So it should return 1. If you return 1, that's going to be different. Yeah, it returns 0. So that's a problem here. It should return result. It should return the result. If you return 0, that's going to be a 0. So that's my mistake here. All right. So that's all for all the multiple choice questions in chapter 18 of the Java book. Thank you for watching. Goodbye.